As a science student, you need to understand the basis of chemistry. This is an introduction to chemistry. Watch it to the end of the video. You will love it. Um, Good day, everyone. Sorry for the late video. So we are going to introduction to chemistry. Introduction to chemistry. So in this video we will talk about the most important things you have to know about chemistry. You understand? So let me just say the preliminary, the basis things you have to know. So in chemistry, like first of all, what do we know about chemistry? We must first of all define chemistry. The word chemistry. What do you think the word chemistry means? Understand? Chemistry let me just say is a branch of science or branch of studies. You understand? It's also a subject, something we study, something like deal with studies. Yes, study of what? Study of everything that is present in this life. And anything that is present in this life, we call it matter. You understand? That you can see that exists in this life, we call them matter. For example, look at this. Is a matter. Why is it matter? Matter is anything that has mass and can occupy space. If I put this pen here now, it occupies the space or it does not occupy space. It does. So, and if you put it on a scale, you understand, on a weighing balance, it has a particular mass. So, in short, we say chemistry deals with what? Matters. You understand? So, in normal definition, we say it is a study, you know, that chemistry is a study, you understand, or you understand, study of matters, matters. When you're just talking of matters, you can't just be saying that, well, what are matters? Where do we see matters? The moment you are talking of what are matters, where do we see matters? Well, what are matter doing? What are they doing? What is the function of matters? You are talking of its its properties. So when you are talking of its properties, oh, maybe this pen, you ask it as a matter now. This pen has a cover, its properties, its cover, case. You understand? So its properties. What do we use it for to do all these things? So. We also talk about composition. Its composition. You understand? What the meaning of composition? How is it made? How is it made? Like what is it made of? Yes. Oh, this pen is made up of one plastic cover. This case is like glass, although it's not glass, but it's just like glass. So they use glass. They use plastic or rubber. They use this. They use that. They use ink. You understand? These are its composition. But properties is just like, okay, what are the things it has? Okay, it has cover, it has case, it has. But property composition, what is those properties made of? You understand? What are those properties made of? Like, oh, those properties are from leather, they are from rubber, they are from ink, they are from tin, they are from iron, they are from. You understand? These are its composition. So when you are talking about matters in chemistry, you are studying in matter in chemistry, you must talk about its properties, its composition, and hmm, changes that occur to it. So any changes that occur to those matters. Example, maybe you put this pen inside fire. What happened to this pen? It burns. The pen has changed, right? Okay, this pen, if you put it inside hot water, what will happen to it? I don't know. If you grind this pen, you pour it something will happen to it. So those changes that occur to it, we can in short call it its reaction. Reaction. So changes that occur to those matter, we can also call it reaction. Just as if I'm a gentle guy, I don't stress anybody. I just sit down gently. Somebody just come and slap me. Over. So as he slap me, you understand? As a normal person, I will react. I will change. I will do something. Right? That thing that I do is a reaction. The same thing that happened to this thing. If you put a matter, maybe a pen or a cleaner or any object, you put it inside fire or you react there with another thing. Example, just give me Gary. Have hot water. Garri is a matter, hot water is a matter. You just add garri inside hot water, you will see it will change its form suddenly. So its reaction with water. You understand what I'm saying? So it changes our occur to that garri. So Studying of all these things about a substance is called chemistry. About a matter is called chemistry. So in chemistry now, what we'll just do that is we are just be dealing, we will just be dealing with matters. And what is matters? Matter matters are anything that has mass and can occupy space. Well, let's see. If I use this, let me just get something as a matter. So this is a matter, you understand? I put this thing here. It occupies a particular space or it doesn't. So you can't see what I wrote underneath. So it occupies a space. Let's bring on this scale. Uh, you can see this. It is what weighing 0, 0. The moment I place this thing on it, what does it measure? What does it weigh? 2.35. It has that is its mass. It's 2.35 gram. So its mass is 2.35 gram. So this thing has weight and it can occupy space. It is therefore a matter. So studying of anything about this thing is chemistry. Studying of its properties, its composition. Okay, what are the properties? Okay. It has something like white something. Okay, it has something like nylon. Okay, now composition. Oh, this white something is made up of maybe plastic or something like this like something like nylon. Oh, it's made up of something like carbon. You understand? That is its composition. But changes that occur to it. What can happen to this thing now? Okay, maybe if I add acid to this thing, what will happen to it? Okay, maybe if I put this thing inside fire, what will happen to it? That's the reaction. You understand? So matter is anything that can what? That has mass and can occupy space. So do you understand that? So now let's go to chemistry. Now chemistry has two branches. Like it just divided into two. Majorly into two. We have the organic chemistry and inorganic. So the anywhere you hear organic, inorganic, anytime you hear organic, just believe something coming from animal or plant. So anything coming from what? Animal, sorry, animal, animals or plant. So inorganic will be anything coming from what? Inanimate or plant. Something that is not animal or plant, e.g. soil, abi, is not let me use not, you understand? E.g. soil, rock. So you understand? So they are inorganic, soil, rock, all those things that are not from plants and they are not for animal. You understand? So they are what? So if I say wood now, is a wood organic or inorganic? Wood is organic because it's from plants. So if I talk of roofing sheet, roofing iron sheet, something called it, that is it organic or inorganic? Inorganic. Why? You can't see roofing sheet from plant or animal. Abi you can't just tell me because elephant is called erin. So you will now if you now call the stomach of elephant, you now see iron that is bent inside elephant. They will now bring it out and use it to do what they want you to do. The person is lying for you. You can't see iron inside elephant. So which means that iron it is not what? It is not organic. So let's go. So anytime you are talking of organic chemistry, it will be branch of chemistry, you understand, or study of you understand of matters that can be found in plant or animal. You understand? You understand? Matter that can be anything that can be found in plant or an animal. You understand? So most of those things. And inorganic chemistry will be something it be study of matters that can be found in what? In non-living things, abi? Non-living things. So soil, rock, etc. like that. So all those things that you can find inside soil, find inside soil, find inside rock, find inside, you understand? All those things are what? E.g. iron, uh, uh, calcium, you understand? Calcium. You can find calcium inside what's it called? Inside rock, find it. Water, safe. Water, here. And bachelor, do you know that water can be found in animal and plant? Yes, it can be found. it can be found, but pure water cannot be found there. So when you're talking of water, it is actually what inorganic. You understand? So etc etc. And for the organic compound, so we'll be dealing with maybe let me just give you like, so in plant maybe like oil, you understand? You can find something like carbon, carbon in plants like wood. Wood is a carbon, is consists of most of carbon, like so on and so forth, etc. So now we talk about the matter. Now let's now bring about that matter. What composed of matter? Okay, now what is that thing? We said that this thing is a matter, right? That anything that we can see that has mass and occupies space is a matter. Now, how can we now say that okay, this matter, what do you contain? We have already talked about matters, right? Now we want to talk about is composition. We want to talk about it what? Composition. How is this matter formed? Who formed this matter? So these people don't sit down. So the olden days philosophers, they sat down and they think about it. If these things are made up of little little things that would they add them together and form these big things, how are we sure that this thing is made up of tiny tiny particles? How are we going to know? They started cutting, 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 cutting. So maybe if I cut this thing to two, I still cut it to two, cut it, cut it, cut it, cut it, cut it, cut it, and I continue cutting. Maybe this is a long thing I was holding, so I started cutting it, cutting it. So the one I cut it, I still cut it again, cut it like this, cut it like this, cut it like this, cut it like this, cut it like this. So as time goes on, I will have one particular particle that is very tiny. So a tiny particle, you understand, that could not be divided anymore. So you now find a particle that is very tiny that you can't divide it again, that is very, very small. You cut that into one pieces that you find that it's very small that you two can't cut it again. Baba, you don't try. So a particle, a fine particle that could not be what? Divided anymore was formed. So those that was formed, you understand, was named. So that particle, they now name it atom. You understand? So that particle they call it what? Atom. So that thing that you can't divide again is called what? Atom. See, this atom is present in this thing. This is a very small particle that cannot be divided. So they now add them together to now form this thing. The same thing in this one too. It is a particle, it's a tiny particle called atom. They add together, add together, add together, add together. I don't know the person that had it. Maybe it's God, maybe it's woman. I don't want to know. So it was just added together, pam, 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 till it's formed these big things. Do you understand? So which means all the things that are formed in this life are formed from atom. But this atom, are they the same? No. So okay, you mean atom that we found in this glass will be quite different from atom that we found in rubber. You can see that most of the time, if this thing now, I can bend this thing or I can't bend it. I can bend it. Can I bend this one? No, I can't bend it easily unless I want to break it. Which means something that formed this one is quite different from this one. You understand what I'm saying? Or can I just say atoms of this are the same are different from this? The combination of many atoms, boom, from them, right? Which means atom of this are quite different from this. Something that is present in this is not what is present in this. So at the same time, we can just they now sit down like say, okay, now since atoms of this one is quite different from what atoms of this one. So everything that we have in this life, you understand? Let us give them names. You understand? Let us give them names so that if we give them names, we'll be able to differentiate their atoms. You understand? Okay, now if you say all the students of our Kwara State, all of you should come here, boom. If they come, how will you differentiate them? That's why every school has its names. So you now say, okay, and do you know that? So you now say, okay, what is their name? Okay, Adiola Enekan High School, stay here. Boom. Some people will stay, some people will not stay. Old Grammar School, stay here. Of a grammar school, stay here. Pam. So all the students, you separate them according to the name of their school, which means you will separate atom, you understand, are differentiated according to the name of their element of their element. So now, the name you give one school, you understand, the name you give to a school, maybe Okinola High School, that name, you understand, differentiate them, those students from others, right? The same name we give elements, the same name we give those elements that will let us differentiate their atoms. So elements will be like school. So the name we give to those elements, the difference in those elements, you understand, will let us differentiate their atoms. So you know every school is different. Adiola school is different from ODS, right? We have named them to be Adiola, to be ODS. So you will name every element. When you're talking of element, element means a thing or anything. So you name those things. Okay, this will be calcium. Oh, this will be hydrogen. This will be carbon. This will be aluminum. This will be iron. So you have give them different name. Okay, this is a pen. Oh, let's call this one a cover. Let's call this one those are elements. So if you can differentiate, oh, this is a wood, this is a iron, this is a, so the moment you give them names, you understand, you give them names, you will be able to differentiate their atoms. Like, atoms of iron, this is how they always be. Atoms of wood, this is how they always be. Atoms of rubber, they always do like this. So it is because you are able to differentiate those students into different groups. That's why you are able to know their you'll be able to differentiate their what atoms. So now every student that now stay on the queue, maybe they wear the same uniform for Adiola, so OJS to wear their uniform, something like that, something like that. Every school was not there. One student among them will represent atom here. All of them are from the same school, Abi. Let's call it an element. So if I take somebody out of them, maybe I just take one person, one boy or one girl. Hey, you come out, come and represent your school. It's as if you take an atom of elements. That hey, let this atom represent this element. Okay, well, this is an iron, but I can't just carry a whole iron. If I want to know anything about iron, let me just take small particle out of iron. You understand? Let me just take it. It can help me to represent iron. You understand? I will know what is composed in iron. That's atom. But falling enough, is it possible that one student, can it be a school? Like one student now, can it be a whole school? Like ODS, Old Grammar School now. It should not be like only one student is there. Only one student is in science, art, and commercial. That one student is the only student that ODS is now having. Is it possible? Well, a student cannot be a school. Before you can call something a school, it will be like an aggregation of many students that are learning together, right? Good. Which means atom, you understand? Atoms, let me just say an atom. An atom, you understand? Eh, is indivisible. Who remember this indivisible method that I said? Indivisible, you know, where you cut something, cut it to the level that you can't see anything again. Apart from one particle, that you can't cut them again. You can't divide it anymore. Indivisible. You understand? Indivisible part of an element. You remember, it's as if you take one student out of the whole school. It's as if you take atom out of its element. You understand? Atom, indivisible part of an what? Element that can not take part in chemical reaction. So those things, after you have called them to the pieces, they cannot take part in chemical reaction. The same way one student cannot be a student in one school. It can represent a student, but it cannot do like a whole school. Oh, you don't understand what I'm saying? Like you can take one person from ODS, come and represent your school. But you can't say this person is the whole ODS. Is it possible? No. So which means if I want to play football now, I can't take one student and say this student is the whole student of OGS. So come and play football with us. You other school are 11. You can't take one person from OGS that you 11 want to play with one person. Is it possible? Which means atom can never take part in chemical reaction. You can't just take that small particle and small tiny particle that cannot be divided again and say that this thing will react. This thing will help us to do this thing. It cannot possible. It cannot do anything because it is very tiny. It's too small now. Just as if I take small grain of sand and I put it inside a storage of water, like a tank of water, boom, and you tell me that that water is contaminated. Grain of sand, just grain of sand. It is not even we know it's contaminated, but you can't feel it in water. But carry like cup of sand, put it inside, you know that you will know that they had something inside that tank. So everybody you see clearly, why now? So the aggregation of sands, you understand? You understand? They will help us to represent. You understand? They will represent our element well, and they will act like, you understand? They will act like that element. But atom can just represent, but can't act like that element. Do you understand? So let's go. Now, these atoms, you understand? Atoms, let's just go. When we have atoms, atoms of the same element are always alike. Like they will look the same. You understand? They are the same. The same. You understand? But opposite, you understand? But different, sorry, but different for from other other elements. You understand? So they will be different from what other elements. So atoms of the same thing, they are always alike, but different from what other elements. Please, do you understand? So when I'm saying that they will be different from other elements, so they are always different from other elements. So now what we have to do now is that when you now add atom plus atom plus maybe another atom, you understand, two or more atom, two, you understand, or more atom atoms of the same element. So you add two or more atoms of the same element, they will give you a molecule. You understand? So a molecule. So when you talk of molecule, what is molecule? Molecule is the what? Is the what? Is the combination of what? Two or more atoms of the same element or different element too, or different elements or different elements. So it can be the same element, it can be different elements, but you shall add two or more atoms, it will give you molecule. But compound, it is opposite, like opposite to molecule. So it's just like what? Atoms of different elements. So atoms of different elements will give you compound. Like before you can call something a compound, there will be many houses in that building. You understand? So in that area, so we call it that place. We call it, there are many houses in that place. So if you call it a compound. So before you can call something a compound, it will be like two or more different elements, e.g., carbon. You understand? Maybe atoms of carbon and carbon and iron and maybe calcium and hydrogen and etc. Just add them together, boom, boom, boom. But molecule, it can be, maybe we have e.g., we have oxygen, you understand, plus oxygen, maybe atom of oxygen, you understand. You have like chlorine plus chlorine, atom of chlorine plus another atom of chlorine, you understand. And it can be atom of different elements. It can be even be like, maybe you have like atom of nitrogen plus atom of oxygen. You can see they are different, you understand. To give you maybe like NO2, atom of oxygen plus atom of oxygen, you give, or maybe oxygen gas, atom of chlorine plus chlorine, give you a chlorine gas, so you understand. So and so on and so forth, like that. So this is the difference between what molecule and what compound. So now when I'm talking of molecule, you should be able to know that molecule is the what? Combination. What have we learned so far? Molecule, combination of two or more atoms. Compound, combination of atoms that are of different elements. Please, atoms that are of different elements. So whenever we're talking of molecule, you should be able to know. Whenever we're talking of compound, you should be able to what? So, can molecule take part in the chemical reaction? Yes. It's not very tiny, it consists of two or more atoms, so it will be very big. You understand? For you, it's call something molecule. Combination of two or more atoms, ultimately B.C. So which means it will have become more bigger, right? It can participate in chemical reaction. That is, you can feel it when they do something to it. Maybe the oxygen now, maybe let me give you now. molecule of this oxygen now. You understand? They put oxygen, molecule of oxygen, they put it where something is burning. Oxygen will make that thing burn. Zoom, zoom, zoom. But if you just take one atom of oxygen, you put it there, that thing can burn. You can't even know that. You can't even know that you add oxygen to it. So combination of two or more oxygens, like oxygen atoms rather, that plenty, you now put it inside where something is burning. It will make that thing burn faster. You understand? So molecule can participate in chemical reaction. Compound can also participate in chemical reaction because it consists of two or more atoms. So, but atom it cannot participate in chemical reaction because it's just one entity. It's very tiny, something like this, so it can't participate. So from now, I hope you are able to understand what is meant by atom: a small particle that cannot be divided. Molecule, compound. We talk about chemistry. What is chemistry? We explained to you that chemistry is a branch of study that deal with what matter, its properties, composition, and changes that occur to that matters. So what is matter? We say matter is anything that occupies space, mass, and that has mass and can occupy space. Now we on the branch of chemistry. Now so we have organic compound, organic chemistry, and inorganic chemistry. So which is chemistry that deal with the study of matters that can find in what plant, animal, chemical, and what inorganic will be your study of matters that we can find in what non-living thing, living, you understand, so, and so on. So I from this video we are able to know what is an atom, compound, and so on. Now let's go to the an atom. You understand? Atom. So atom. Already we talked about that atom is anything that has any particle, right, that cannot be divided, that we have already that cannot take part in chemical reaction. Yes, fine. We've talked about that. There are many other things we have to know about atom. So if you can know atom, you already know chemistry. Because most of chemistry will be dealing with combination of many atoms together. So now how can we now what are the special things we have to know about atom? So what we just realize is that in every element in this life that we have, it's just as if you say in every school we have in this life, you will have students, I mean you will not have students. So in every element in this life, you have atom. Although their students will be different. So although their atom too will be different, but do you know that there is something that's always common among students? What are those things? When you see a student must wear uniform, at least from our cloth. He or she must wear cloth, shoe or sandal, socks, carry bag. So those things are common to students, right? Even though they are different, they are from different schools. So atom of different elements are different, but there is something that's always common to atom. What is it? Atom must have something in the center like this. So from now, atom will be like a feed. So like ODS football feed, Adiola's football feed, so let's just use atom to represent feed now. So every school has different feed, but there is something that's always common to their feed. There must be there must be track that you will draw for sports when you are doing entire sport. There must be they must have grass on their feet. They must have somebody that will be every time to monitor somebody that is running on the feet. They must have students that is running on the feet. So now let's just say atom equal to school feed. So now that feed we have something in the middle, we call it center. You understand? At the center. That's something at the center. That's something at the center now. You understand? It's like somebody monitoring those students that are running. You understand? So we now have students that are now running. Students that are running. This is students that are running. Students that are running. They are running like this. You understand? They are running like this. Running like this. You understand? Students that are running. Before there was no track for students to know that this is how we run. They will just be running, circling around the field. So and these people will be monitoring them. So as time goes on, these spectators that are monitoring the students that are running, they now discover that some students are doubling. Some students, instead of them to run away from the center, they are now running towards it so that they will be able to complete many cycles as possible before so time. Within a few times. So they just be like, what can we do? Let's see, let's check the distance of this student to the center, distance of this student to the center, this student. I think this one is longer than this. What will happen is that let us draw a track for them so that they will be running on that track. So if you can draw a track to them, so they will just be running on that track. That track will be the guide for them to be running. Now the spectator in the middle, you understand, we call them nucleus. The students that are now running, we call them electron. But the distance between this nucleus, the spectator, and the electron that are running, you understand, enable us to draw a line that they are running. So with that line, we call them shell. shell. You understand? We call them what? Shell. Or energy level. So that shell, but note, most of us will call it shell. So those shell is where the students are now running. Broom, 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 broom. Students are now what? Running on that shell. Do you understand? So students are running on the shell. Now, this spectator, the nucleus, there are two people that are always monitoring the students. Number one, we have two external bodies. Your teacher will be there. Every teacher will be for every house. Maybe teacher of maths, our math teacher is in yellow house, our chemistry teacher is in blue house. They will be defending their children, right? No, 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 my children was swing. No, even if their children do something wrong, they won't be able to shout that, hey, you have crossed the lane, because they know is their what? Student. So they won't want to shout. But there is outside spectator. Outside spectator, they don't have any house. Maybe you go and rent somebody like referee. The person don't know maybe this is blue house or red house. You have to pay him or her. So the person will always be like, okay, they must not cheat. Anybody that cheats, I will file them. I will send them out. I will do clinic on, because the person don't send you. So the person is that person that you borrow from outside. You understand? That did not care about any house. The person is neutral. It's not supporting any house. It's neutral. Like, it's not supporting any house. It's not doing anything. So the person that is neutral is called neutron. 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 But your teacher that's always wants their student to be the winner. We are run now, Tomake, run now. They are proton. So this proton and electron, there is connection between them. So inside this nucleus, inside this center of the field, there is teacher and spectator, right? That is, there is proton and neutron forming the nucleus. The proton, which is the teacher, will be attracting their student. They will tell them that run now, please now, don't let this house loose. But the neutron, which is the spectator, you know, concerned. If you like, no wrong, you know, concerned. So neutron is not even participating. He's just looking at them like this. Anything you like, may you do. But proton, he is always what? In charge of what? Electron. So there is connection between electron and proton. So electron is said to be negative. You understand? Electron is what? Is negatively charged. You understand? Why proton is positively charged. You understand? So proton is what? Positive. Electron is what? Negative. You understand? It's just like normal thing that always happens. Student that is running will be tired. Oh. I can't run again. I can't come and give myself. Teacher will always be like, run, please, run, please, run, please. Teacher is positive, the student is negative. You understand? But this man, I'm a spectator. They are neutral. You don't really concern them. If you like, no wrong. Do you understand now? So this is what is present in atom. It's like feed. So every school must have, every student of school or must have source, bag, normal student. I'm not talking of school B. The school A students, not school B. They must have source, bag, shoe, uniform. The same thing, atom of every other element. They must have something we call electron, nucleus, shell. Although the arrangement of electron will be different on every other atom. But in the same thing in school. Some school will wear blue cloth as uniform. Some school will wear yellow. Although they wear uniform, but can be different colors. The same thing. This atom, we have atoms of different elements. Maybe you have, this is element of iron. This is iron. Iron. Let me not say element of atom of iron. Maybe now have atom of calcium. Atom of calcium too will also be like this. You understand? Electron will be there, electron will be there, electron will be there. But the arrangement of the electron on iron will be just different from arrangement of electron on calcium. That's the only thing that will be different among them. So the arrangement of what? You understand? The arrangement of electron on the shell of calcium will be different from arrangement of the shell of what? Iron. That's only the difference between students of different school. Their color of their uniform or school or bag may be different, but they will wear uniform, which means it must have electron, but only the arrangement must be different. You understand? So these are the things that is unique among them. They must have shell, nucleus, electron, so on. But the arrangement is different. I hope you understand that. Now, let's proceed a bit. And I need to add one thing. Do you remember that if we have four house, normally we always have house, red, blue, yellow, or white house, as we always have four house in four computers in school. So if you have red, blue, yellow house on feed, the teacher that will be inside this center or mid feed will be what? Will be teacher for yellow house, teacher for red house, teacher for blue house, and white house. They will also be four. So which means on a normal circumstance, on a normal circumstance, the number of electron must be equal to the number of proton. The number of teacher of, you understand, that is teacher that is saying please run now, run, positive teacher proton, that is advising the student that is tired, negative student, that to run, they must be equal number on a normal circumstance. What are the abnormal circumstances? Maybe the neutron, the spectator send one of the students away. Hey, run! Okay, come out for the field, though. You are crossing somebody else lane. I will cancel this thing for you. Yeah, run, come out for the field. So the what happened? The number of students will reduce, but the number of proton will still be the same. So students, they can send away the student from the field, but they can't send away the proton from the field. So in the atom of every other element, what happen is that maybe from Adiola, when they are running now, if any student misbehave, they can send like three students from the field and leave all their teachers. In other school, they can send students away from the field and leave their teachers all. They won't send teacher away. Which means we always risk that the number of electron can change. That is, the number of students on the field can change at any time. But the number of teachers in the center can never change. So that thing, we can use them to identify atom. So people now come that, okay, wait. So they now say that, how can we now differentiate this atom? Let us give this atom number. It's just as if you want to give school that are in offer, you want to give them number, maybe let me just say, you are giving them number OGS, number one, clinic on number two. You want to give them number, right? The same way they used to give the name other elements, they give them number. So the number of those atoms, we call it atomic number. You understand? So from there, we now get something we call atomic number. So let's go to the new page. So from here, we have what we call atomic number. What is atomic number? It is the number of proton, that that is present. You understand? You understand? That is present. Number of proton that is present on the shell of every atom of every element. So we know, you understand, we told us in the previous time that atom of the element have electron, electron that is revolving on the shell. It must have what? Nucleus in the center, but it must have electron. Okay, let me redraw. This is a nucleus, you understand? This is a shell, and it must have electron that is what? Revolving, that is running, you understand, on the shell, revolving around the nucleus. You can see it's revolving around the nucleus, but on the what? On the shell. The pathway that this electron is passing is on the shell. But how is it running? Running around the what? The nucleus. So let's go. Now, the number of those electrons that are there. Sorry, the number of electrons that are there. Note, atomic number is not number of electron. We can some teacher will tell you that atomic number is the number of electron that is present on the shell. Yes, it is true. It is number of electron. But remember, sometimes electron can run away from the field. Why? Maybe the electron is tired, the student is tired. You can say, well, I can't come and kill myself, I'm not running again. But the teacher in the center, which is proton, the proton is always equal to the number of electron. So if electron can run away, teacher will not run away. What is that thing that is always constant? Whatever I mean constant, that is always there. Proton will be always there, which means proton will not change. No matter what happens, no matter even if the house is losing, teacher will not run away. You understand? But students can run away. If the student is shy, he will run away. But the teacher will not run away. So we can say that proton is that thing that's stable. So we can call atomic number is the number of proton that is present not on the shell, that is present in the nucleus. You know, proton is always in the nucleus of atom of every element. You understand? Where some people always say that it is number of electron, which although it is true that it's number of electron, but don't forget, electron can run away. So it is better to call atomic number of proton. You understand? It is better to call it number of proton instead of saying that it is number of electron. Although it is still correct, oh, let me just say it's not actually number of electron. So because although it is correct, oh, but sometimes electron can run away or electron can hard up. You can hard up electron or electron can run away. It is possible that electron will come to the field or electron will run away. You understand? It can happen. So now, so the number of those electron or proton are called what? Atomic number. Please, do you understand this? If you don't understand, pause the video and replay what I said. So I think since we know what we call atomic number, you understand, we need to know the arrangement of electron on the shell of an atom. Arrangement of electrons on the shell of an atom. So the arrangement of electrons on the shell of an atom is called what can we call it? Electronic configuration. Electronic what? Configuration. So anytime you hear electronic configuration, it is always what? Arrangement of electron on the shell of an atom. Do you understand? So it is called electronic configuration. So where we use atomic number, which got what? Number of electron. Bachelor, are you the one that said that atomic number is not number of electron? Yes. Here we believe that atomic number is atomic number of electron for us to do this electronic configuration. Because we can't know how the teacher can't arrange themselves on track. Why? Okay, now let me tell you something. Atomic number is number of proton. No, it is true. But do you know that in this center, you can't tell the teacher to arrange themselves. The spectator they cannot command the teacher to arrange themselves. Spectator, which is nucleus. Do you remember? Spectator is nucleus. So spectator is neutron. You understand? Neutron equal to spectator. Those people that we borrow from outside that is come and help us to monitor students, they are inside. The teacher is the proton. The student that is running is the electron. So now, the neutron, which is the spectator, they can't tell the teacher to arrange themselves in the middle. Why will you be telling the teacher to, hey, teacher, be on this track? It is impossible. But they can command the student to be on the track. That is, they can arrange the students on the track, but they can't arrange the teacher. So, which means, since you can't arrange proton, but you can arrange the electron, we can use the arrangement of electron to do what? To determine to determine the difference between atom and other of one element and atom of another element. Okay, this is a pen. This is this is a weighing balance. You understand? What can I use to differentiate the atom of this and atom of this? Oh, you go and check the arrangement of their electrons, because their teacher is not always arranged, which is proton, but the electron is arranged, right? So we can use the difference between the electron of this and electron of this to determine the what, the type of what, the type of atoms it's present, like the atom of atom that thing is present in. Look, just like, okay, so if you now know the difference between the difference between the arrangement of those elements, of the atom of those elements, you'll be able to differentiate between them. Like, okay, if you go to iron, their electron on the shell of their atom, they are always arranged like this. Okay, for example, now you want to differentiate between Adiola school and OGS. What will you do? You go to their feed when they are doing inter-house sports. Okay, how did they arrange their students? Oh, they put yellow. OGS always put yellow house on lane 1, blue house on lane 2, white house on lane 3. The arrangement is what? Electronic configuration. Arrangement of their students, arrangement of electron. If you go to Adiola can say that black house be on lane 1. You can see it's quite different from OGS. White house be on lane 2. You understand? So very different arrangements. So the different arrangements will help you to know that, oh, anytime I see black house on lane 1, I know that it is Adiola. Oh, anytime I see blue house on lane 1, it is OGS. Do you understand? So that is how we differentiate between those atoms. So when they say that, what is the benefit of electronic configuration? You understand? To differentiate, to what? To differentiate benefit or importance of what? To differentiate or importance of electronic configuration between atoms of different elements. So we used to differentiate between atoms of different elements. Is that clear? Is that clear? So if you don't understand, please pause the video, or I'll take it back. Like, just go back to the previous. You understand? Like, do the backward. You understand what I mean? Double tap by your left side. So by the left side of the screen, you will be able to have access to it. So now we have to differentiate between the atoms of different elements. Now, on the electronic configuration, we call it what? Arrangement of what? Electron on the what? On the atom of shell. Now, how do we differentiate electrons? How? How do we differentiate electrons? I'm sorry, how do we differentiate atoms using their what? Electrons. How? We have we have for now, for your level, you understand? We have two rules. We only have what? Two rules for your level, please. We have two rules for your level. Two laws for stability of shell / arrangement of electron on shell. Now, they say that we have two rules. Number one, what's the first rule? First law. We have law of duplex stability. Law of duplex what? Stability. What do you mean of duplex? Anytime you hear duplex, you should know that this means two. Anytime you hear duplex, duet, two. So what is the law of duplex stability? It states that the first shell, that is number one shell of an atom can only accommodate or allow two electrons. You understand? For its stability. So he said that what? He said that on the first shell, like this first shell, you understand? This, let me say, this is the nucleus. This is now the first shell. If this is first shell, the only electron you can add to this first shell is two. So if you have add two electrons to this shell is totally occupied. So it's totally occupied and not ready to, you understand? It's not ready to lose or gain any electron. So if this shell has two number of electrons, first shell, if you can add two electrons to the first shell, which means it is totally enough. It can't add any electron again. Like first for every school, for every atom, their first shell, you can only occupy how many electrons? Two electrons. So after the moment you added two electrons like this, you can't add anything on that shell again. Bachelor, what if the atom now have many electrons? What will happen? We will go and create another shell. You can't arrange them on the first shell again. So that first shell is saturated already. When something is saturated, it is full. It is enough. So now, second law of duplex stability. Now, what does that law say? You understand? Duplex, not duplex. Octet, please. Octet stability. Anytime you hear oct, like octagon, it means 8. You understand? It states that, you understand, the second shell and other shell and other shell of atom of an atom. You understand? Apart apart from the first shell. So apart from the first shell, other shell, maybe the second shell, third shell, fourth shell, apart from the first shell, can only accommodate 8 electrons to become stable and not ready to lose or gain any electron. See that's this law that the second person say. Is that what? Law of octet stability is that this any other shell apart from the first shell, the only first shell can take 2, it will become stable. It can't take any electron again. Second shell, you can only add 8. So the moment you add 8 electrons to it, you can't add any other thing again. If you have another electron, you still draw another shell. That's how it goes. So the second law says that apart from the first shell, second shell and another shell can only take what? 8. So if you know these two rules, you are free in chemistry. You understand? So now, now there are other things we have to talk about. Now, in this second section, we talk about atomic number, which is the number of proton in the shell. We can also call it number of electron. But why don't we call it number of electron? Because we say that electron can give out sometimes and electron can enter. So electron varies most of times. And we talk about the electronic configuration. We say it's the arrangement of electrons on the what? On the shell of an atom. So electron can be arranged. How can electron be arranged? Is either the arrangement of electron on the shell, right? I will say how electrons are arranged. This is called law we have two laws, law of duplex stability and law of octet stability. So law of duplex stability said that what we can only add 2 electrons on the first shell, and the other shell we can, for law of octet stability, what happen to them that we can only add 8 electrons in the second or other shell before they can become stable. So if you have any other electron, you go to another shell, you can't add them to that shell again. And those shells that have 8 electrons, they can't collect more or add, you can't add more to them, or they can, and they are not ready to lose any of them again because they are already filled up. But if they are not filled up, maybe it remains small to fill, anything can happen to them. But if the moment they are already saturated, they have become stable. That's what they call them stability. So they become stable. Like when we mean stable, somebody is not going anywhere again. Or burn me, I don't stable alone. So you understand. So that is that about that. Other things we have to know about this thing is valency. Valency.